Okay, it says find the second derivative of this curve at the point P found in part B. There's a period. You don't want to keep reading. You should stop, do what they've asked, don't keep reading. You want to get as many points as you can by doing what they've asked for. You notice over here, you're actually going to earn 2 points if you can answer this part, even if you can't answer the rest. You need to keep reminding yourself you don't have to get every single point right on the AP test to pass. So we just want to do what we can, move slow and careful, not get in a rush, but we do want to do that little part before we worry about something else. So I have back here, this was in part A, and so that little piece, I'm going to copy that over. That I already know. So I start with that, and I need to take a second derivative. So now I do need the quotient rule. So I take the bottom. So let's see, the second derivative, d squared y over dx squared will equal. The bottom must be in parentheses, multiplied by the derivative of the top. Minus, because it's the quotient rule. Let's move these out of the way for a minute. We'll put that up there actually. The bottom, see the top now, must be in parentheses because it's minus the entire term, or both terms. You must have the parentheses. We practiced that a lot with the quotient rule. Don't forget the dx over here. Dx, not dy, because x is the input variable. Multiplied by d over dx of the bottom. All of it is divided by the bottom squared. It says find the value of the second derivative at point P found in part B. So this is going to equal 8y subtract 3x. For this derivative, it's 3 multiplied by the derivative of y, so that's 3 dy dx. Don't forget the parentheses. The derivative of 2x would just be 2. Like that. All divided by 8y, this should be squared, 8y subtract 3x all squared. Okay, we're supposed to find, I do this a lot on problems that just are difficult. I've done this much, I go back and reread again, find the value of this at the point found in part B. So the point found in part B was P was equal to 3, 2. But that was the point where the slope of the curve was equal to 0. So that means at that point, dy dx will equal 0, because dy dx means the slope. So if I'm trying to find, I'm going to have to move some things, hold on. So I'm trying to find the second derivative. At 3, 2. So plug it in. 8 multiplied by 2. Subtract 3 times 3. This is 0. This is also 0. And this is where we're really glad So we're doing an FRQ test, not a multiple choice, because at this point, all that's left to do is add, subtract, multiply, and divide. We don't have to keep going. We get to there. Don't forget the squared. You should stop. You don't want to keep going. Just make sure you have all the right parentheses. If you have this exactly as written, exactly as you see it, you earn 2 points. Because it was worth 2 points, I would say that if you had this box, but you didn't know how to keep going because you didn't remember that at the point they are asking about, dy dx would be 0, you would still get one of the 2 points. For the second point, you must have this box. If you keep going and find the exact numeric answer, you'll still get the second of these 2 points. If you keep going and get the wrong numeric answer, hold on a second, I misread this. That's actually 3 points so far. So you're getting, if you can get to here, you get the first 2 points. If you get to here, you get the third point. So here's the third point. And now we have to finish the question, which we'll do in a second. So one more time. The first 2 points were for getting to this box correctly. The third point was for recognizing that at x equal 3 and y equal 2, dy dx is 0. That gives you, and then plugging in the x equal 3, y equal 2. That gets you this box. That would be the third point. Okay, one more time. You really should stop here. But in case you kept going and I want you to be able to grade the work, we're going to copy this. And keep going here for a minute. So on this page we'll do a little erasing here. Get some space. So to get this third point, you should have just stopped here. But if you happen to have kept going, this is tricky. I don't want to do that either. If you kept going here, let's see, this is going to wrap back up to here. You would have had 16 minus 9 times negative 2. Oh, this is convenient. 6 minus 6 is 0, so this is gone. The bottom would have been 16 minus 9 all squared. The numerator is factored. Factors are 16 minus 9 multiplied by negative 2. The bottom is 16 minus 9 multiplied by 16 minus 9. That means those two factors can divide. And you're left with negative 2 over 7. You do not need to go that far. I would have stopped here. I would not have kept going. If I get to here, I'll get that third point. Now for the fourth point, let's make another copy here. Cut this off. The question says, does the curve have a local max, a local min, or neither at the point P? Okay, my golden notes told me this. That the curve has a relative max when the derivative changes positive to negative. But all I know is that at point P, so So at P, slope of curve, it's always better to write than just think, is 0. So that means the curve could look like this, or like this, or like this, or perhaps like this. I'm supposed to figure out which. I don't have a graph. I can't do a sign chart of the derivative because the derivative has x and y. I've only done sign charts with x, so I don't know how to see when f prime changes from positive to negative or vice versa. So a tricky problem. Make sure you don't get stuck on it, but here's how you can solve it. You also have a formula now for the second derivative. They do this a lot on FRQs. They kind of set you up. So we found that at P, the slope of the curve is 0. We also know at P, second derivative that has a value of negative 2 over 7. So looking at Danica's chart, we can figure it out now. We know that the curve looks like one of these because of the first derivative equaling 0. So at P, the slope of the curve, we need to write that down again. P equals, we did that earlier, but just to make sure the grader can see it. So P equals that at slope P, the curve, because I have to have a justification here. So at that point, the slope of the curve is 0. At point P, the second derivative is negative. So when the second derivative is negative, the curve must be concave down, so it has to be this one. So then I can write, therefore, the curve, there's no name for this curve, the curve has a relative max, you can abbreviate, at 3, 2. I probably want to make sure just maybe one more thing. At this point, this equals this, so curve is concave down at, this is a valid abbreviation, 3, 2. So that's enough to justify everything, plus get, so that's what you would need to get this last point. That last point I would say is rather tricky, but that's what you would have had to have done to get that point.